In this video, we're going to be covering dilations. Dilations are geometric transformation that changes the size of an object or shape by decreasing or increasing its dimensions by some scale factor. This is the first transformation that is going to be changing the size. The previous ones, rotations, translations, and reflections, did not change the size of the object, but this time, this one is going to do that. Because this one is going to be changing the size of the object, this is not going to be considered a rigid motion. Only the previous three were rigid motions. The center of dilation is going to be a fixed point in the plane about which all the points are going to be expanded or contracted. Let's say we have a triangle A. If we dilate that triangle, we are going to need a center of dilation. This is going to be our point of reference. That means that our shape, our triangle A, is going to be increase or decrease in relation to this point right there. Let's say that for this example, we're going to get our shape A, and that's going to become larger. So the distance between the point and the figure is going to increase as well. So now you're able to see that when you dilate triangle A and you make it larger, that distance between the center of dilation and our image is going to increase as well with our new image. Keep in mind that this is your A, your original, your pre-image, and this is a prime. You will see that relationship between the distance in the next portion. In order to perform a dilation, we're going to need a scale factor. The scale factor is going to be a ratio of the length of the corresponding sides of the image and the pre-image. If the scale factor is greater than 1, the image will be enlarged. So in this case, we have R is greater than 1. So our pre-image, our original image A, is going to be dilated and is going to become a larger shape. That's why we have A prime on the next one. But that's not always going to be the case. Sometimes your scale factor is going to be between 0 and 1. Whenever the scale factor is between 0 and 1, you're actually going to be reducing the image. Your image is going to become smaller. In this case, we have A, and A is going to A prime. So the larger image is going into the small one. Example 1. Find the scale factor of the dilation. So the first part that we need to figure out is if we're going to be moving into a larger image or into a smaller image. So for that, we're going to be paying attention to the notation. In this case, you have P and P prime. So we're going to be moving from the small one, because this is going to be our pre-image, and we're going to be making it larger. To be able to find the scale factor, we are going to be using a formula. The formula that we're going to be using is L prime is equal to the ratio or your scale factor times your original length. In this case, we have our original length being 10. So that's going to be in the portion where L is. So we have 10 right there. We're looking for the ratio, so that's the information that we don't have. The last portion of information that we have is the distance between our center of dilation, which is C, and P prime. So that distance is going to be 25. So that's going to be our new length. So L prime. So we're going to put 25 right here. In order to find the scale factor, we need to leave our R by itself. So we need to use inverse operations, and we're going to divide this side by 10 and this side by 10. That means 25 divided by 10 is going to give you 2.5, and that's going to be equal to R. So our scale factor is going to be 2.5. From this point right here, this distance is 10. The whole distance is 2.5 times bigger than our original one. Let's look at another example. Example 2. Find the scale factor of the dilation. In this case, we're comparing the sizes of paper clips. So in the first one, we have P, which in this case is going to be the large one, and then P prime is your smaller one. So we're moving from a large object into a small one. That means our scale factor is going to be between 0 and 1. Once again, we're going to use our formula. So we're going to put L prime is equal to R times our original length. In this case, the length from the bigger paperclip P to our center of dilation is actually 30 units. So we're going to start with R times 30. We don't know what R is. And now our length prime, so from P to our center of dilation, is going to be 18. We're going to use inverse operations once again. Divide by 30, divide by 30. Now we need to reduce the fraction. I know that the greatest common factor between 18 and 30 is 6. So I'm going to divide the numerator and denominator by 6. So 18 divided by 6 is going to give you 3. 30 divided by 6 is going to give you 5. So that means that our scale factor is going to be 3/5. That's okay. This is going to be less than 1. 3/5 is less than 1. So we know that we're making our shape smaller. Now use the next two examples as practice. Pause the video and solve this problem. Pause the video and solve this problem. Now we're going to be dealing with coordinate rule for dilation. If P is going to be a point in our coordinate plane, like right here, and we have the coordinates of that point P as x, y, that's going to be our original point. Then the image, so P prime, is going to be the multiplication of our scale factor R times x and our scale factor y times R. So that means that our point prime is going to be, for example, in this case, P prime is going to be at x times R, comma, y times R. And our original point was just x, y. You can use this information to find the scale factor, because in this case, they're going to give you a precise point and the original point, and then you can put it back into our formula. In example 3, they're giving you a triangle that you have to graph at the precise points. We're going to graph each point and make sure that you label it. So our first point, A, is going to be at 2 and 1. So we are going to go to our origin, this is 0, 0. Our first number is our x. So we're going to move 2 units to the right because it's positive and 1 unit up. That's going to be our first point. The next point is at 4 and 1. So at the origin, 1, 2, 3, 4, and 1. So that's our B. And the last one is at 4 and negative 1. And this is going to be our point C. We are going to connect the points, and that's how we find our triangle. Now that we have our triangle, it's telling you that we need to dilate it by a scale factor of 2. So what I want to do right here is I want to make a little note. So we start with x and y, but now our new one is going to be 2 times x, because we're going to, again, multiply it by the scale factor of 2. And the next one is going to be 2 times y. Once again, we just get the y value and multiply it by the scale factor. The first point A is at 2, 1. If we multiply 2 times 2, it's going to give you 4. If you multiply 2 times 1, that's going to give you 2. So that means that our A is going to be at 4 and 2. And for this, I want to use a different color so you can see it. The next point is going to be 4, 1. When we multiply by the scale factor of 2, 4 times 2 gives us 8. 2 times 1 gives you 2. So our next point is going to be at 8 and 2. So this is A prime and this is B prime. And now we have to do our last point. That's going to be 4, negative 1. Once again, we're going to multiply by 2. And that's going to give us 8, negative 2. So we go to 8, negative 2. And that's going to be our new point. So now we can just connect the shape. In this case, we say that our blue shape technically covers our label. So I'm just going to mark it again, but a little bit further. That's going to be our original B. So this is how we can use the coordinates to graph the dilated figure. Pause the video and use this problem as practice. Example 4 is very similar to example 3. In this case, you already are given the image, so we have K, L, M, and N. But they're not giving you the scale factor in words. They're going to give you the scale factor in symbols. In this case, it's telling you that we have X and Y is going to be multiplied by 1/3. So technically, our scale factor right here is going to be 1/3. Since 1/3 is going to be less than 1, we know that our image is going to be getting smaller. So we're going to start by writing the coordinates. So the first one, we have -3 and 6. Multiplied by 1/3 is the same thing as dividing by 3. So we have 3 divided by 3 is going to give us -1. Then we have 6 divided by by 3. That's going to give us +2. That's going to be our first coordinate. The next one is 0 and 6. 0 divided by 3 gives you 0. 6 divided by 3 gives you 2 again. Then we get 3 and 3. We know that each one divided by 3 is going to give you 1. So our next coordinate is 1 and 1. And lastly, we have -3 and -3. -3 divided by 3 is going to give you -1. And once again, -1. Now we need to plug these points and connect the lines. Once we grab the 4 points, we get the blue image, which is 1/3 of the length of each side. Pause the video and use this problem as practice. Now, this is the last example, example 5. In this case, we need to find the scale factor. To find the scale factor, again, we're going to use the points. So our original image right here is going to be B, X, and W. You can choose any of the points. I like to deal with positive numbers, so I'm going to use point W. W is at 3 and -2. 3 and -2. And we know that that's going to go to 9 and -6. So 9 and -6. The only thing you need is find the number that when you multiply to 3 gives you 9. I'm going to go over the formal way of doing that. So this is your original one, and then this is your prime. So you can do 9 is equal to our ratio or scale factor times 3. Divide by 3, divide by 3, right side cancels, and now you have R is equal to 3. So that's our scale factor. Pause the video and solve exercise 5 for practice.